Hello and good afternoon. This lesson is titled Isosceles and Equilateral Triangles, and in this video I'm going to give you examples of how to use isosceles triangles to figure out angle measurements and how to set up equations, and also with equilateral triangles, how to use equilateral triangles to set up equations, and of course, and review how to solve those equations. Let's begin by first going over what an isosceles triangle is. Well, an isosceles triangle are any triangles where two of the sides and two of the angles are congruent. They're equal to each other. Now, with an isosceles triangle, if you notice here, the two sides, as you see indicated here, and the two angles that are congruent are on opposite sides of each other. So as you see here, this side and this side are equal, and their adjacent angles are going to be equal. So the adjacent angle to this side is this one, and the adjacent angle to this side is that one right there, and those two things are going to be equal. So like example right here, as you can see right here, this is a right angle here, but it's an isosceles triangle because this angle here, this side here is equal to this side here. As you see, I'm focusing on this triangle here in case you lost me. And because those two sides are congruent, it's an isosceles triangle. And well, since this angle is adjacent to this side and this angle here is adjacent to this side, then those two angles are also going to be congruent. So let's look at an example of this type of situation. So here we have an isosceles triangle. We're trying to figure out the measurement of angle J, which is this angle right here, and angle K. You know what, let's switch colors. Let's put orange instead. So, sorry, let me erase this. So that's this angle up here, angle K, that one angle right there. Well, since this side is congruent to this side, as again indicated by those markers right there, then that means that this angle is congruent to that angle right there. So this is also going to equal 68 degrees. So angle J has an angle measurement of 68. Well, the way we're going to figure out the measurement of angle K, again, is use the same rules that we used in the previous lesson on the Triangle Sum Theorem, that the interior angles add up to 180 degrees. So getting 180 degrees and subtracting 68 and 68, which is equivalent to subtracting 136, we end up with 44. So the measurement of that top angle there is equal to 44 degrees. Let's look at a second example. Here we have a second example, and we're trying to identify now the angle measurement again of angle C, which is up here, and angle E, which is down there. And we want to know what the angle measurement is going to equal to for those two. Well, we're given a third angle up here, and that's 106. But again, using the Angle Sum Theorem, I know that the sum of these three angles, the orange, the yellow, and this angle right there, has to equal to 180. So getting 180 and subtracting the 106, that's equal to 74 degrees. Well, the 74 degrees is going to be split up among these two angles. And because these two angles are congruent, again, equal, they're the exact same number, this 74 is going to be broken up into two equal parts. So to figure out the measurement of those two angles, I'm simply going to get 74 and divide it by 2, which is equal to 37. So the measurement of angle C is 37. The angle measurement of angle E is also 37. And I can verify that this is going to be true because adding 37 plus 37 plus 106 is going to add up to 180 degrees. Again, 37 plus 37 plus 106 equals to 180, because this is 74, and 74 plus 106 is 180. So I know, again, this has to be correct. Again, checking the work, these two angles have to be that. So again, this one, again, these two being equal, the remaining angle measurement of 74 has to be then divided into two equal parts. So now let's look at this side right here. Here we're looking for a side and an angle measurement. Well, let's start with the angle measurements, because that's simple to do. Since these two angles are equivalent, we're looking for the angle measurement of y, which is up there. So getting 180 and subtracting it by the 77 and this 77, which is equivalent to 154, we end up with 26. So this is equal to 26 degrees. Now, the way we're going to figure out the measurement of this side here from point Y to point Z is, well, we have an isosceles triangle again. And I know it's an isosceles triangle because these two angles are the same, which means these two sides, their adjacent sides, are also going to be the same. So this side and the opposite of that side are going to be congruent. So the side length of YZ is also going to equal to 12 centimeters. And again, the units, well, I'm not going to write the units, 12. So 12. Now, solving equations on isosceles triangles. Well, just like again before, the key idea in understanding what isosceles triangles is knowing which of the two sides are congruent. So again, since these two sides are congruent, that means that these two angles are going to be congruent. And because they're congruent, that means that they're equal to each other. So the way I'm going to solve for this equation is to get 5x plus 9 and have it equal to 8x minus 30. And then with our whole letters to our left and numbers to our right technique, we'll have the 8x subtracted on the left side. We'll have the 9 subtracted on the right side, and we end up with negative 3x is equal to negative 39. We divide by negative 3, and x is going to equal to 13. Let's now look at an example again where we're using isosceles triangles to solve 9 equations. Now here, we're not told that the two sides are equal, but that we are told that the two angles, 74 and 74. So since these two angles are equal to each other, then that means that these two sides are going to also be equal to each other. So 9x minus 73 is equal to 3x plus 23. So letters to the left, numbers to the right. We'll subtract 3x, add 73, and we get that 6x is equal to 96, and we're going to divide by 6. And our answer is 16. So again, on these last two examples, they'll have to provide you one of the two things. They'll either have to tell you that the two angles are equal, indicating that we have an isosceles triangle, or they'll have to tell you that the two sides are congruent, again meaning you have an isosceles triangle, so these two angles are equal to each other. And again, with that information, you can set up your equation by getting the two angles set equal to each other, and setting these two sides, again, congruent, set equal to each other. Now, if a diagram isn't given to you, well, then you just simply have to look at what's given to us, and we're going to draw a triangle and make it look like an isosceles triangle, since we are talking about isosceles triangles right now. And we're going to see what the letters are that are going to be congruent. Well, again, before I name the triangle RST and put the letters R, S, T in any random order, again, I'm given the fact and I'm told that these two sides are congruent. Remember this symbol right there? the little equal sign with the squiggly line on top. Again, the approximation symbol. I hate to call it squiggly line, but the approximation symbol on top right there, that's our symbol for congruency. So we're indicating, again, we're given the fact that RT is congruent to ST. So we're going to go from R to a point T, and then from S to a point T, and those two sides are going to be congruent. So I'm going to put the T on the very top because my diagram, I've made these two angles be congruent. So T would have to go up there. So I could have this side, RT, and ST be the exact same size. Now, since those two sides are congruent, then that means that these two angles are angle R and angle S are congruent. Well, we're told that angle R is, let me highlight it, is 9x plus 2, and angle S is 13x minus 18. They also even tell me that angle T is 17x plus 1. But we're not going to use that to figure out the measurement of angle, or I'm sorry, the variable x. So let me just highlight where angle T is. Angle T is going to be up there. But again, since we have an isosceles triangle, angle R and S are equal. So we can solve for x by having these two things equal to each other. So with letters to the left and numbers to the right, we'll subtract 13x, move this over, make it a negative 13, move this to this side, making it minus 2, and we have negative 4x is equal to negative 20. Dividing by negative 4, we find that x is going to equal to positive 5. Alright, so perfect. X is equal to positive 5. So let me move this out of the way. Let me put it down here. Let me put, there we go. All right, so x is equal to positive 5. So now that we have that the value of x is equal to positive 5, we can figure out the angle measurements of R, S, and T by substituting in those values. So for R, we'll replace the x with 5, and we're going to end up with 47. 9 times 5 is 45, and then plus 2 is 47. For the measurement of angle S, it's 13 times x, but again, when we replace the x with 5, this is equal to, let's see, this is 15. 65 minus 18, which is 47. So also 47, which, duh, I don't know why I even did that, since I know that angle R and angle S are equal, and if angle R was 47, angle S was obviously going to be 47. That's the whole purpose of even doing this, of setting those two things equal to each other. So I don't even know why I did that, and now that I'm thinking about it, I shouldn't even bother even doing that expression. I should have automatically picked up that it was going to be 47. The only one I do not know is going to be T. R is not going to help me figure out T. I can do and figure out the measurement of angle T by doing one of two things. I can substitute in the x with 5, or I can simply get 180 degrees and subtract this 47 degree angle, subtract this 47 degree angle and this 47 degree angle, which is the equivalent of subtracting 94. So my answer would be 86. So 86 degrees, which is exactly what happens when I multiply and I substitute in 5 for x right here. Okay, you're going to see that when I multiply 17 times 5, that's equal to 85, and 85 plus 1 is equal to 86. So those are the two ways to figure out the measurement of the last angle. Okay, again, you could use the angle sum theorem, knowing again that these three angles has to add up to 180 degrees. I would take away the 47 and 47 to get 86, or plugging in 5 for the value of x in this expression for t. Still gives us the same answer of 86. Let's look at another example. Again, here we're going to figure out the segment lengths. Okay, we're going to figure out the 3 side lengths in a triangle, but to do that, we first need to figure out the value of x, because again, DE is x plus 4, EF is 4x minus 8, and DF is 7x minus 35. So let me start by first drawing a triangle so I could visualize this better. And we're told that these two angles, angle D and angle E, are congruent. So I'm going to label D down here and E also down there. And those two angles are congruent, which means that these two sides, let me highlight it instead. Well, no, let me just stick it in blue. These two sides are going to be congruent as well. Those are also going to be the exact same length. So F would have to be up here. So angle D and angle E are equal. So that means that DF and FE are equal to each other. So DF and EF are equal. Well, DE is x plus 4. So from D to E, that's x plus 4. E to F is 4x minus 8. And F, wrong side. E to F is 4x minus 8, wrong side. And D to F is 7x minus 35. So again, those two blue sides are equal to each other. We're not given angle measurements, we're given sides, the measurement of the sides. So those two sides are equal to each other. So getting 7x minus 35 equal to 4x minus 8 will solve the equation for x. So with letters to the left and numbers to the right, we're going to subtract 4x and we're going to add 35. So we get that 3x is going to equal to 27, and dividing by 3 we get that the value of x is equal to 9. So let me move this, let me move this over a little bit, okay, so I have some more room. So now with the value of x equal to 9, I can figure out the measurement of DE. DE is going to be, let me highlight again, these two are equal to each other. But DE, which is this bottom side down here, that's equal to x plus 4, and with x equal to 9, 9 plus 4 is equal to 13. So that segment down there is equal to 13. And well, the two blue segments are going to be equal to each other. So this time I'm not going to make that mistake of having to do double work. So let me first figure out the measurement from D to F. From D to F, that would be 7 times the value of 9 minus 35. Well, 7 times 9, that's equal to 63. And 63 minus 35 is equal to 28. So D to F is equal to 28, which means that E to F is also equal to 28, because again, those two sides are congruent. So I'm not going to make the same mistake and do more work, because again, these two are going to equal to the same number. And if you don't believe me, again, plug in a 9 right there. 9 times 4 is 36, and 36 minus 8 is going to equal to 28. Now for equilateral triangles, now moving on to equilateral triangles. Equilateral triangles are triangles equilateral. Let me rephrase that. In a triangle is equilateral if and only if the three angles are equal to each other, then the three sides are equal to each other. So the side length from A to B is equal to the side length from B to C, which is going to equal to the side length from A to C. So that means that these three sides are equal to each other, and vice versa. If the three sides are equal to each other, then the three angle measurements are equal to each other. The measurement of angle A is equal to the measurement of angle B, which is equal to the measurement of angle C. And those three angle measurements are always going to equal to 60 degrees, because 180 degrees divided by, so like I said, because since the angle measurement, like I was saying, since the interior angles in a triangle add up to 180 degrees, and all three angles have to be the same, 180 divided into three equal pieces is going to equal to 60. So your angles are always going to equal to 60 degrees on an equilateral triangle. So that makes it a little bit easier to figure out and set up equations, because if I know we have an equilateral triangle and I am missing this angle, then I know it has to be set equal to 60. So for example, the measurement of angle C again has to be 60 automatically, because it's an equilateral triangle. So I know the three sides are all going to measure 9, and all the three angles are going to have to measure 60. And this time it's 9. It's not always going to obviously be the side lengths. The side lengths could be bigger. Since this one is 9, then these three are going to be, the other two are going to be 9. But all the three angles are always going to be set equal to 60 degrees. So right here, since the three sides are equal, then that means that the three angles are also going to be equal. So all three angles are going to equal to 60 degrees, and since this side is 24, then these two sides are also going to be 24. So the measurement here, they're asking about the angles. Angle J is 60 degrees, angle K is 60 degrees, and angle L is going to equal to 60 degrees. So that makes it a lot easier. Now, to set up equations and to solve equations, well, the idea again is the same. If we know that the triangle is an equilateral triangle, then we know that all the angles have to measure 60 degrees. So for this one right here, to figure out what the value of x is here, I'm simply going to get 7x minus 3 and set it equal to 60, because again, that's this measurement r, the measurement of this angle, which is 7x minus 3, has to be the same as 60. So solving this equation, we would get the following. We would get, add 3, we would get that 7x is equal to 63, and dividing by 7, x would equal to 9. So that we solved for x. Well, to figure out the value of y, again, on an equilateral triangle, all three sides are the same. So if I get this side, let me use red. If I get this side, it's going to be equivalent to any of the other two sides. So I can set it equal to 9y plus 1, or I can set it to this side down there. Well, I only need to set it to one of the two sides, so I'm just going to simply set it to the one I've already highlighted in red. So 14y, not x, 14y minus 59 is going to equal to 9y plus 1. Or I could have had 9y plus 1 equal to this one right there, or like I said, 14y minus 59 and set it equal to that one. As long as I get two of the sides equal to each other, I'm going to figure out the value for y in this situation. So now with letters to the left, the numbers to the right, I'm going to subtract the 9y, I'm going to add the 59, and I'm going to get 5y is equal to 60. Divide the 60 by 5, and I get that the value of y is equal to 12. So those are your solutions for x and for y. So again, with the equilateral triangle, figuring out setting up the equations is relatively easy. You just simply have to get the two sides equal to each other, and to figure out the measurement of the angle, you just simply have to get your expression and set it equal to 60. So again, thank you for watching this. I hope this was very helpful and these examples were clear for you to understand. Now, if you haven't done so, again, please subscribe to my channel so you can get updates to when I upload new videos. When I upload new videos and new lessons there. So again, thank you for watching, and I hope you have a great day.